Today we are going to talk about science at Vidyakshetra. Science means exploring the way of acquiring knowledge and actually acquiring it. In Vidyakshetra, we have developed a very unique methodology of teaching science. Science really starts at a very early age for children. Really 4-year-old, 5-year-old go out and observe what's happening around. And slowly that observation changes into doing experiments to actually figuring out why that is happening. Applying that knowledge to create technology and understanding the science behind those technologies. And really connecting the dots of each technical element, each physical element, each experiential element to a higher understanding or a higher knowledge. Today I want to present to you something which we did with the 14-year-old in Vidyakshetra. This is a block which was conducted for light. Children understood various concepts of light and various experiments were done to understand those. What we're going to see today is how those concepts got applied into creating a technology and how did they understand how the technology which was being taught to them, the concepts which were being taught to them, how they came together to solve a problem. The methodology of physics you would see is experiential in nature, which means experience the happening, observe what is happening, analyze it, and conclude out of it. In Vidyakshetra, for example, for physics, the light chapter, we didn't have any books to refer to. We only had phenomena, experiments, and observations. Today we are going to see how 14-year-olds understood how light principles got applied to create something like a periscope or a kaleidoscope. For science, we have created a list of 250 experiments which we run through with children to help them understand various different concepts. Once this topic is light, this is what we're going to see today. When we started our experiments with periscope and kaleidoscope, prior to starting these experiments, we learned the whole concept of reflection.
So if this is Y, this is also Y. And what is the angle between the incident ray and reflected ray? 2Y. 2Y. Now, this is my original figure. This is my original mirror. Now I have rotated the mirror. This is my new perpendicular. If I rotated the mirror by 20 degrees, you have X degrees. This perpendicular will also rotate. इसी को ऐसे ही rotate किया ना मैंने.
The science of reflection, the laws of reflection were understood with a series of experiments. Now the obvious question arose, if we know these laws, how do we apply this? Why are they useful for us? And that's when we applied some of these concepts into something tangible. And we said, oh, okay, so if we have to figure out why reflection is important for us and where it should be used, we started with the periscope. We understood why periscope is constructed the way it is constructed.
If this is my mirror and this is the object, ray comes and goes back. What is the angle between incident ray and reflected ray? 0 degrees. Now by how much should I shift this mirror so that the angle of reflection becomes 90 degrees? The angle between the incident ray and the reflected ray is 90 degrees. I have to do it 45 degrees. Because if I shift it by 45 degrees, the angle changes by 2x. 90 degrees.
So we should get angle of incidence or angle of reflection total. We should get 90. That is why we shift it.
That is why we shift it by 45 degrees. That is the application we did in the periscope. Why am I putting at 45? If I ever ask you a question, why periscopes have angle at 45 degrees, you should be able to explain me this. What?
Children actually constructed the periscope, saw it working for themselves, and understood why it is working the way it is working. That involved, getting their hands dirty with creating a periscope, which means getting a cardboard, getting mirrors, putting them all together, actually going in and using that periscope, what they built, to be able to solve a specific problem.
What you should write with periscope is steps क्या हैं बनाने के लिए.
Procedure लिखना.
उसका observation क्या रहा? I was able to see through. एक observation ये रहा मेरा क्यों नहीं बना? एक observation ये रहा कि मेरा stable क्यों नहीं था?
Similar thing with kaleidoscope, right? They actually ended up building a kaleidoscope using the concepts which they learned in the class, saw it working, and related that working to the concepts which they had learned before.
Kaleidoscope में क्या हम what are we going to use as a principle? क्या पढ़ा हमने kaleidoscope में क्या किया? आपको पता नहीं है kaleidoscope क्या होता है? Kaleidoscope is a triangular figure we are going to make. Okay.
उसके अंदर वो कुछ तो बीट्स डाल के ऐसे घुमाते थे वो वाला
So I am going to use 3 mirrors, all facing inwards. Triangle बनाऊंगा. Each mirror is of the same size.
Same size.
Same size. Which means, what is this triangle?
Equilateral triangle.
Equilateral triangle, right? Equilateral triangle. Angle of each
60 degrees.
60 degrees. You know what I am doing now, no? If I put the mirror in
तो डबल हो जाएगा
So if I put an object here, I see 5 images.
और फिर उसमें भी रिफ्लेक्ट हो
उस 5
जाएगा
images का 10 यहाँ पे बनेगा और ये इसका. Now we're going to make this and see. We're going to make this and see. क्या make करेंगे हम? I'll give you, what am I going to give you? 3 mirrors of the same size, rectangular size. स्टेबल बनाना है, ऐसा नहीं बनाना है. थोड़ा स्टेबल बनाएंगे, हाँ? और थोड़ा डेकोरेट भी कर सकते हैं. Now, what we are going to do? Understand, okay? I am going to tape it up, fully tape it up, so that it becomes stable, it becomes intact. The 3 mirrors, okay? Then I can put a wrapping paper on top of it. I can make a design on that wrapping paper also. What am I going to do on one side? So there are 2 triangles on each side.
Yes.
एक साइड पे क्या करेंगे हम?
एक ट्रायंगुलर कार्डबोर्ड पे एक होल बनाएंगे
ओके, एक ट्रायंगुलर कार्डबोर्ड डाल के एक होल बनाएंगे, through which I am going to see.
और एक और तरफ ब्लॉक कर देंगे. नहीं, बटर पेपर लगाएंगे.
बटर पेपर लगाएंगे.
थोड़ा लाइट आना चाहिए, आधा दिखेगा ही नहीं.
थोड़ा लाइट आएगा और फिर उसके अंदर हम कुछ कलरफुल ऑब्जेक्ट्स डालेंगे.
Beads.
And then we will turn it around and see, and we will count the number of images we are seeing. Number 1, and number 2, we will see the designs which come up because of all of this.
अन्ना मैंने किधर से पढ़ा था कि कैलेडोस्कोप में जो पैटर्न्स दिखते हैं वो again we don't see the same. It is different every time.
Because as you move, the position cannot be the same.
Is this yours somewhere?
Huh? This is a toy. Just to see that it looks beautiful. The designs which come out are beautiful. Okay. These are mirrors of the same size. So 3 of them can make a. So how will you do this? How will you do this? How should it come? This is how it will come. हाँ?
अंदर से एक्चुअली जोड़ेंगे तो वो 60 डिग्री आ जाएगा.
हाँ आएगा ना? क्यों?
हाँ?
तो मेरे को ऐसा बनाना है. ठीक है ना? Let's do it.
एक बताता हूँ
Anyways, after this, it was
And giving you 2 sheets. One could be your place, the other one could be your design work.
It was a great experience for the children. You could see that some of the children were able to explain in detail how the building of the kaleidoscope happened and why they were able to see what they were able to see. When we did the kaleidoscope experiment, we divided the team into 3 groups. So we wanted essentially 3 different kaleidoscopes to come out. The children worked in groups. Teamwork was the essential element of what they worked for. We analyzed their teamwork as well at the end of the experiment, not only the concept. And at the end of it, children did make a working kaleidoscope and were able to explain why they had, in a kaleidoscope, why they had mirrors at 60 degrees, for example. Why they were able to see different design patterns which they were able to see, and that was very exciting for children.
थोड़ा अरे इतनी कोई क्यों कर रहे हो?
Leave it here, just a bit extra.
बाकी why don't do the other two guys? You take this paper and do also and you do this. No, this is the
What's your make it so much colorful? I know water color sides.
Can we call the show here? One idea.
बहुत अच्छा बना
we are closing.
एग्जाम
What paper लगे आपका?
Yes, it is wrong. Twist it.
दिन में काम कर रहे हैं तो घर में कैसे काम करें?
Two and three.
Team 1, team 2, team 3. किसका सेकंड टेस्ट लग रहा है? हाँ? टीम 3 का सेकंड टेस्ट लग रहा है?
Team 2 का लग रहा है।
टीम 2 का लग रहा है? Team 2 I think was most efficient as they were doing their work. Huh? Team 2 was most efficient in doing their work. They were able to do it fast. They were chit-chatting less. And they were able to do it more efficiently and faster.
You will see that during the course of the experiment, not only did they learn how a periscope, for example, works, there were new problem statements given to them, and they were asked to apply what they have learned in a new scenario, in a new problem statement. Right? What we are trying to develop is the thought process of applying science to create technology, of identifying problems and solving them, of really understanding the problem statement and seeing how the current technology could be modified to solve the new problem statement. For example, when we built the periscope, we spoke about how ships use them to spying. But then people did analyze how would they rebuild this periscope if they have to view something across the wall. Not really at a height, but something across the wall. What would change in a periscope to really build some of those technologies?
मतलब अगर मैं यहाँ से बॉल ले तो वो जो यहाँ पे मिल रहा है इस पे हम यहाँ फिर ये जो ये मिल रहा है इस पे
So there is an exploration of existing technologies, and there is an exploration of how a newer problem could be solved by applying the same concept in a different scenario. At the end of this whole thing, we only understood as much as we can explain it to others, and we do the same thing with our children. So they actually end up explaining what they have understood to the rest of the class in their own way. Both the concept and how that concept got applied to what they actually made, the kaleidoscope as well as the periscope.
The periscope is an instrument which contains a rectangular shaped cardboard and two mirrors placed at 45 degrees for reference. Then we mark with the protractor, then we mark one line at 45 degrees. We make a kaleidoscope at 3 slabs of mirrors. And light is going in that. So we have this is the order. Listen.